In this lesson, we're going to take a look at how we count atoms, and we count atoms using a balance. We can weigh them out, and we use moles to convert between grams and number of atoms. So it's easy to go from moles to particles and from grams to moles. It's just a unit conversion. We're going to take a look at that. So like I said, converting between mass, moles, and atoms is the same process as unit conversions. Here's the unit conversion that we need to go from moles of stuff to particles. Remember, 1 mole is 6.022 times 10 to the 23, just like 1 dozen is 12. And remember that something's atomic mass in AMU is equal to its molar mass in grams. They're numerically equivalent. So suppose I have 43.2 grams of iron. How many moles of iron do I have? And how many atoms of iron do I have? This is pretty straightforward, but I'm going to need some information. So I have 43.2 grams, and I need to know how many moles I have. So that means I'm changing grams into moles. And to do that, I need the molar mass of iron. And the molar mass of iron can be found with a periodic table. Right here is iron. We see that it has an atomic mass of 55.845 grams per mole. That's its atomic mass in AMU, but it's also its molar mass in grams per mole. So 55.845. Iron has a molar mass of 55.845 grams per mole. Now remember, I'm trying to get moles of iron. So if I have, this is the same thing as 55.845 grams over moles. If I want to get moles, then I need my grams to cancel. So I'm going to multiply by the reciprocal of this. So 43.2 grams times 1 mole per 55.845. And now on my calculator, I can just go ahead and bring that in. Go 43.2 divided by 55.845 and get 0.7736. 0.7736, and this is moles. Okay, that's how many moles of iron I have. Now the next question there is, how many atoms of iron do I have? Well, since 1 mole is 6.022 times 10 to the 23, I can take 0.7736 moles times 6.02 times 10 to the 23 per mole, and this is atoms per mole since I'm dealing with atoms of iron. If it was molecules, then it would be molecules, but this is per mole. So then again with my calculator, and this is a handy way of doing this, so I can just go times, because that's my answer, and then 6.022 times 10 to the 23rd is 6.022, and then I'm going to push second EE. It's right above the comma there. That is the scientific notation button, and now I can use 23, so the calculator understands that is 6.022 times 10 to the 23rd. Push enter, and it tells me my answer, and it is in scientific notation. Shouldn't surprise us. 4.66 times 10 to the 23rd equals 4.66 times 10 to the 23 atoms of iron. Okay, so the first thing we did was we got the molar mass. Molar mass, we can use it as grams per mole, but we can invert that thing, which is what I did, and use it as moles per gram. And then I was able to get moles. And then I just took my moles times my per mole, my Avogadro's number there, and I got how many atoms of iron I have. We'll look at one more example problem. We're going to go the other way from moles to grams. A reaction requires 4 moles of Cu2O. How much should you weigh out? So in order to do this, I'm basically asking, this is how many moles I have, how much mass do I need? So Cu2O is not an element, it's a compound, and so I need to determine the molar mass of Cu2O. And I'm going to do this by using the periodic table again. So I'm going to grab my periodic table, and I see copper is right here. It's got a molar mass of 63.546, and oxygen is 15.999. So with that in mind, I can say over here I have 2 coppers, and remember the molar mass of copper was 63.546. And I have to add on to that my 1 oxygen plus 1 times 15.999. And I'm going to use my calculator, type that in, and we get 143.091. 143.091. And the units on this is grams per mole. So if I need 1 mole of copper oxide, I would use 143.091. But I need 4 moles. So 143.091 grams per mole times 4 moles. Moles cancel, and I will know how many grams I need. 4 times 1 is 4, 4 times 9 is 36, carry that, 4 times 3 is 12, 16, 17. 143.091. So 4 times 1 is 4, 4 times 9 is 36, 4 times 3 is 12, 4 times 4 is 16, carry that, 17, and so this should be a 5, 72.364 grams.